I am about to kick off your presentation. You will have like half an hour, give or take, plus time for Q&A. And if you could, oh, there you are. I see you. Unfortunately, you do not see me. You look wonderful. And guys, everybody please send questions to Susannah at slido.com. It's on your Hopin app or directly in the Slido app. And Susannah, if you could share your screen and show us your presentation. Excellent.
Perfect.
We see everything.
Can you see it?
And now the audience will hear you also loud and clear, and I go off the stage. Please welcome Susannah Shattuck, everyone.
Great. Well, thank you all for being here. I am very sad that I am not with you in Budapest, one of my favorite cities in the world. I've spent a lot of time there, and I know that this is a fantastic and very fun conference. So I hope you all have been having a lot of fun so far, in addition to all of the great learnings. So I'm going to be talking about what it actually means to build responsible AI in this new era of large language models. And very specifically, I'm going to be sharing some examples from the field of different ways that you can manage and mitigate risks of your AI systems, whether you are building and training LLMs from scratch. Good on you if that's what you're doing. Or if you are, the more likely scenario, right, is you might be using an out-of-the-box model, whether it's an open source model or something from OpenAI, Anthropic, or Cohere. How can you ensure that the systems that you're building with these large language models are not going to be harmful, are not going to cause the downfall of humanity or society as we know it? There's a lot of talk about this. And so we're going to, cut through the noise and get to the reality of what it actually means to build responsible generative AI systems. But first, a little bit more about me. You've heard a bit already, but I'm Susannah. I am currently head of product at a company called Credo AI. We build AI governance software that helps our customers ensure that their AI systems are compliant with laws and regulations like the forthcoming EU AI Act, as well as helping our customers manage and mitigate risks of their AI systems, everything from fairness risk to the risk of hallucinations and toxic, harmful content in the context of generative AI systems. I've been working in this responsible AI space for about the last 8 years. I cut my teeth on responsible AI at IBM. I was part of the very early IBM Watson team, and I have seen pretty much everything go wrong with production AI systems that you can imagine. We were in the Watson team in the very early days of enterprise AI adoption, and a lot of things that we know now about AI systems were not really well understood back then. So, everything from algorithmic bias to data drift to, AI systems that end up getting maliciously attacked while they're in production. I've seen pretty much all of it happen. And so because of that, I've really dedicated my career and now my work to building tools that help organizations and individuals prevent all of those bad things from happening. And if for whatever reason you want to tweet at me on X, I guess, is it still called tweeting? Then my handle is sh_shattuck. So with that, let's dive in. And the first thing I want to say is that there is a lot of noise right now about responsible AI, about generative AI systems, large language models. And so I really want to make sure that in this talk, we are moving beyond buzzword bingo. I really want to get very crisp and clear on helping all of us together understand how to move from principles, these high-level ideals that we have about how we believe our AI systems should or should not behave, to actual practice. How do we actually deploy those systems in a way that is going to be aligned with those values or principles? So we'll be cutting through the noise today, and certainly during the Q&A session, I encourage you to ask questions that are getting down into the tactics of how we actually do this in practice. So with that, let's talk about what we actually mean when we say responsible AI. So this slide actually is an old slide. I've been giving a version of this talk for a couple of years now. And so this is what I used to say were sort of the 5 key tenets of responsible AI when we were dealing previously with predictive ML systems. And these should all hopefully sound familiar to you, right? Fairness, algorithmic bias, and the ways in which AI systems can unintentionally learn harmful patterns from their training data is now a pretty well understood problem. That doesn't mean that it's an easy problem to solve, but the world has really woken up to the ways in which algorithmic bias can be inserted into our AI systems. And there are a set of techniques, including ones that were developed by my former team at IBM, for how you evaluate fairness of your models and then take steps to mitigate them. Transparency, this is a huge focus of regulation. Explainability is really just one piece of transparency. Can we explain individual model decisions and outputs? Another big piece of transparency is how do you communicate effectively to users that they're interacting with an AI system? And how do you explain to the broader societal stakeholders that care what your AI system does and how it works? Safety and security, really critical. How do we ensure that the AI systems that we're inserting into all kinds of really critical places in our world are safe and secure, are not going to be subject to malicious attack or vulnerable to different kinds of attacks by bad actors? Privacy, obviously, GDPR, it drove a lot of thinking around data privacy and the kinds of rights that individuals have. So we need to ensure that our AI systems are preserving individual data privacy rights. And then social and environmental well-being is sort of the biggest, broadest, most challenging bucket. But at its core, how do we ensure that AI systems are contributing to a world that we want to live in, contributing to a world that benefits all, reducing the likelihood of negative or harmful outcomes for different groups, for the globe, for the planet. So these are the 5 sort of original tenets of responsible AI. But as I was working on this talk to think about how to update it for a world that is very different now that we have large language models and we are increasingly building systems on top of these incredibly powerful models, there is a 6th tenet that a lot of folks now want us to add to the conversation about responsible AI, which is existential risk, right? How do we ensure that the AI systems that we're building today aren't contributing to a future where humanity really isn't in control anymore, where we have AI systems that are no longer within our sort of control and within our value system? How do we ensure that we're not bringing about the singularity in a way that's going to crush humanity? That is certainly an important thing for us to think about. It's a little bit more challenging for us to figure out how we solve that with the AI systems we're building today. So I'm going to have the least sort of tactical advice on existential risk, but I do think it's important to call it out in this brave new world that we're living in of these incredibly powerful and truly black box models. So with that, I think the core message of my talk, if you come away with just learning one thing, it's really that these 6 tenets, these responsible AI considerations, need to be integrated into every single step of the development lifecycle if you are building an application that leverages machine learning or LLMs. And I say that because that's generally not the way that people do things. If you are currently building AI systems today, I would bet, I would bet good money that this might be what your development process looks like. Right? You have a whole process, a whole flow that goes from an idea of an application that you want to build through design, gathering the data, training the model, validating that the model works the way that you want it to, deploying the system, and then monitoring the system while it's in production. And somewhere at one point along this line, at one point along this journey, usually it happens somewhere between validation of the model and deployment, there's some kind of responsible AI check-in, some kind of touch base with the governance team or with your compliance team to make sure you've checked all the boxes and the model is allowed to get deployed into production. And I can tell you, because I've seen this firsthand, that this way of building AI responsibly, of inserting a responsible AI check-in into your development process, is designed to make everybody hate governance and hate the responsible AI check-in, right? Because this is a blocker right now between all of the hard work that you've done to build this model and actually getting it into production. So nobody is incentivized in this view of the world to actually do challenging work of really questioning whether the model is going to achieve the outcomes that you want from a responsibility perspective, from a societal perspective, whether the model is actually aligned with your values as an organization. There are so many resources that have been invested at this point into developing this model that it's going to take a lot for you to stop that train. And so because of this, I strongly advocate for people to think about responsible AI check-ins as a parallel, continuous process that needs to happen at every stage of development. And practically speaking, what this looks like is that there are going to be a bunch of different actions or steps that you're taking along the way that are related to answering this question: is the AI system that we're building aligned with our values, our principles, laws and regulations, societal needs? And this is a set of suggestions of what some of those steps could look like. You want to do a use case review. Is this even a thing that we feel is acceptable for us to apply AI to? Is this an ethical use case? Then once you've defined the use case, what are the responsible AI requirements? What are the fairness requirements here? What are the transparency, explainability requirements? Defining those before you actually go into the process of training your model is going to be infinitely easier than having to figure out how to retrofit your model to a set of responsible AI requirements after you've trained it. Then, moving forward, if we're thinking about training LLMs, there's a whole component of that training process where you should be doing red teaming. You should be actively trying to cause your model to break your values, to break those principles, to understand the weaknesses, the weak points of your model, and the ways in which you need to insert guardrails into your application to prevent those weaknesses from showing up for users. And then, of course, you still are going to go through that risk and compliance review that happens at the point of model validation. But because you've been doing these activities all throughout the development process, that's not going to feel like this massive speed bump or this massive blocker. It's going to feel like just a continuous part of your normal development process. Now, very few organizations, probably I can count them on my hands, are truly training large language models from scratch right now. Again, if that's you, if you're doing that, good on you. And we can have a whole long conversation about your obligations and challenges as an LLM trainer around data, around reinforcement learning through human feedback, all of the things that you're going to be doing to actually train a model that's aligned with your values. But most organizations, again, today are leveraging third-party models, whether they're open source models or proprietary models from providers like OpenAI and Anthropic. And so I've modified this development workflow to indicate that there are a couple of steps that change, right, when you are leveraging a third-party model. The first is, rather than training a model, you are doing model selection. You are picking which of the sea of different possible LLMs you might want to use based on your use case. So a really critical step in your governance process is going to be a set of LLM evaluations. And my advice to you is that these evaluations should not just be focused on evaluating performance, making sure that you're picking the most effective model for your use case, but they should also be focused on some of the other tenets of responsible AI that we just discussed. So you should also be considering which model is least likely to produce harmful outputs, which model is least likely to violate your data privacy requirements, your transparency requirements for this particular use case, right? There are different reasons why you would go with an open source model, which might be less effective than a proprietary model, but also give you more control, right, over the data flows, over data privacy for your users. So there are a lot of reasons why you might pick a model that's actually less performant but more acceptable for all of your other responsible AI requirements. So that's a really important thing to understand if you're working with third-party models. The other piece that's going to be different if you're building a system around an LLM is that there are going to be certain risks, certain risky behavior that you truly cannot eliminate from that model. For example, hallucinations, right? There are certain things that OpenAI and Anthropic are doing to reduce the likelihood of hallucinations in their models. But once I, as a builder of an application that's built on top of GPT-4, right, or built on top of Claude, there's not much that I can do at that point to actually change the way that GPT-4 or Claude behave to reduce that risk of hallucinations. So there are going to be other things that I am going to want to do. And I'm generally calling those things guardrails, and we'll talk more about them in a little bit, that I actually build into my application to reduce the risk of my LLM hallucinating and causing some horrible outcome for my users. So there, some examples of these include prompt engineering, system prompts, filtering. Those are going to be things that you very much need to do during the application building process once you've actually selected your model. So just to quickly summarize this segment of the presentation, having a clear view of what it means for your AI system to be responsible throughout the development lifecycle and incorporating those actions and activities into every step along the way is going to greatly increase your chance of success in terms of developing and deploying a model that's aligned with your values. So during design, this means identifying potential risks and harms of your use case and coming up with sort of metrics or measurements that you want to make sure you're evaluating throughout the development process. During development process, this means that you are not just looking at performance, right? But you're also looking at those other responsible AI metrics as you make decisions about either how to train your model if you are training a model, or how to select the right model if you're working with a third-party model. And then, of course, during deployment, it doesn't stop there. AI systems are constantly learning. They're not static. And so you need to ensure that you're continuing to monitor your responsible AI metrics at every step of the system's life cycle and making changes if the system starts to go off the rails. Now, the last point on this slide, I think, is a really important one, because I'm going to guess that most of you in the audience are technical folks who are focused on, technically building and making sure these systems work from a technical perspective. This is not a set of tasks that you or anyone within your organization can or should do alone, right? There are non-technical considerations that need to be taken into account here: legal considerations, ethical considerations, business considerations. And, of course, there are also technical considerations. So this is really a set of activities that requires a cross-functional team to come together and make some really challenging decisions that go beyond just, can we make this system do what we want it to do, but really address core questions like, should we make this system do this thing? And what are the potential risks and harms that we need to track and manage? So with that, I'm now going to go through a little bit more detail and mostly focus actually on this question of how we design responsible AI systems, because I think particularly in the context of large language models and generative AI, a lot of the work of making sure your system isn't harmful needs to happen at the design stage. And then we'll go through actually building the system and deploying the system as well. But starting with designing responsible AI systems, I think there are a couple of really sort of core questions that you need to ask at the start of any AI project that are going to allow you to understand what your responsibility needs to be, what those things that you need to track, measure, and manage are if you want to build a system that isn't going to be harmful. So these are the questions, and they're pretty basic, right? The first question: who is going to be impacted by this system? Now, this is really the most important question in many ways, because if we think about human-centered design and wanting to design systems that are really going to work for a wide variety of different people, you need to deeply understand the people who are going to be not only interacting with your system, but also impacted by your system. And when I say impacted by your system, a great example might be if you're building a system that's a decision support tool for doctors, then doctors are the primary users, but their patients are deeply impacted by that system. So you need to consider the needs and ethical challenges for both the doctors as primary users and the patients as indirect users of the system. Now, the next question, once you've identified who is impacted, what are the potential negative impacts on these people or groups? So we'll continue to use the decision support system. One potential harmful impact on doctors is if they use the decision support tool to make a misdiagnosis, right? The decision support tool leads them astray, then they might face a malpractice lawsuit, right? They might be sued by their patient for making the wrong decision and ultimately causing bad health outcomes. And so that's obviously a challenge that you need to address if you want to get the doctors to use your tool in the first place. What about the impact on the patients? Well, it's not just a malpractice lawsuit that the patients are facing. If the doctor makes a wrong decision using your decision support tool, the patient might have a life or death situation where they end up dying, right? They end up not getting the care that they need. So again, thinking about the impact on all of the groups and the sort of level of impact will help you then understand what you need to address in terms of risks. What is the regulatory context? This is increasingly becoming an important question to ask as we see more and more AI regulations pass. And this is going to really help you rule out different approaches. There might be certain use cases where using an LLM or using a true black box model isn't legally feasible because there are certain explainability requirements. And then the last question to ask, how might we measure and mitigate these negative impacts? You are not going to be able to effectively account for risks and harms during your development lifecycle if you're not coming up with ways to quantify model behavior to ensure that you're minimizing these harms. So if we go back to this doctor-patient medical decision support tool example, if we want to limit that potential harm that the doctor might get sued for a wrong decision, the patient might die for a wrong decision, we're going to decide that the risk of hallucinations of, a large language model producing a completely non-factual suggestion for what the doctor should do is an absolutely unacceptable risk. And so we should come up with ways to measure the truthfulness of our system and have that truthfulness measure be held up as a really, really critical component of how we're evaluating the performance of the system. So we can minimize the hallucinations or untruthful answers that got displayed to doctors. There are a couple of really important things that are true about LLM-based systems that make these different and challenging to really effectively govern. One is that these systems are highly accessible. Given that text is the main input here, almost anybody can interact with an LLM, compared to in the past, more predictive machine learning models having a primary interface that was driven by code in many cases. You needed to know Python to be able to stand up and interact with a linear regression model. Now you don't. When you have an LLM deployed in production, it's literally accessible to anybody who can type text. And then the other challenge is that these are very flexibly powerful systems. They can do things that they were not trained to do at very, very high rates of success. And when you put these two things together, it means that it's very difficult to predict exactly how your users are going to interact with your LLMs. And so it's very difficult to then prevent all of the possible scenarios where your users are going to cause harm. And so that causes rise of a bunch of new risks that we didn't have to worry about before with predictive machine learning systems that we need to worry about now with large language models. And we talked a little bit about some of these already, so I'm not going to go through them in detail on this slide, but it's very important to understand these are net new risks that we didn't have to worry about as much before. And so there still is a lot of nascent research that's happening in helping us understand exactly how, from a technical perspective, to minimize these risks. But one of the things that we can do while we're still trying to understand how to technically limit the risks of these systems is to insert guardrails into our applications. So, some examples of guardrails we talked about before: a system prompt. Having an overall system prompt that guides your LLM to produce the kinds of outputs you want with every single interaction with your users. And I'll show you an example of a system prompt in just a second. Input-output filters, very simple rules-based filters that block, for example, profanity from either your user inputs or your LLM outputs, or block certain keyword terms that you don't want used. ChatGPT has a really robust set of filters built in that prevent people from asking things like how to create chemical weapons. And there are a lot of ways to jailbreak these filters because they're rules-based. So they're not, perfect, but they're definitely a good starting point. And then sort of the most high level guardrail would be a fully human in the loop system, right? Where LLM outputs aren't directly shown to a user or aren't directly used in any way until a human has reviewed them. And some of the most popular LLM tools today that are built into applications are fully human in the loop, right? If we think about the Adobe Photoshop set of LLM-driven capabilities, those are all fully human in the loop. A human user is going to ask an LLM to produce an output, and they accept or reject that output and have the ability to create new outputs if the first one wasn't acceptable. So that's a great way to sort of build an LLM-based system to limit some of these risks that we can't technically limit yet. As promised, I told you I'd show you a system prompt. I think this is probably pretty small, even on the big screen, but hopefully this gives you a sense of the possibilities, the breadth of what you can do with a system prompt. This is a screenshot of the system prompt that was used to guide Bing Chat, which was Microsoft's ill-fated release of basically a way to chat to search the internet instead of a traditional string search. And you can see this is a very long system prompt. So GPT-4 was or I think it was GPT 3.5 was the underlying model that was powering Bing Chat. And for every single response that that model was producing for users, it had this system prompt that was guiding it on how to structure its responses, what to talk about, what not to talk about, etc. I'm looking at the time. I know that we want to transition to questions. So I'll just really quickly share a couple of thoughts on developing responsible AI systems that are related to what we were talking about before. Once you've defined your responsible AI tenets, actually incorporate that into your objective function, incorporate those metrics and measurements of responsibility into the things that you're optimizing for as you're training a model or selecting a model. Evaluate your training data if possible. This is critical for generative AI systems in particular, because these systems are hoovers of data. And so there are a lot of potential unethical pieces of data that might be in that training data set. So asking your model providers what data was used to train this model is going to be really critical to help you understand what are the different risks of whether this model might produce unacceptable content. And then the last piece that I'll just really call out is document every single development decision. Because this is such a nascent space, because we are all learning about this together, right? Trying to understand together exactly how LLMs can be leveraged in a responsible, safe, ethical way. Being clear about what decisions you're making and why is going to be so helpful, not only for yourself and your organization, but potentially a really critical way for you to share those insights and learnings more broadly with the community of researchers and builders that are facing similar challenges. And so with Credo AI, we have a community of practice within our customer base where our customers are sharing with each other the different things that they're doing to ensure responsibility and risk management of LLM-based systems. But there are lots of other communities where this kind of conversation is happening. And I cannot emphasize enough that this kind of documentation is invaluable for driving those conversations forward. So I know that was a lot of material in a relatively short period of time. I want to pause now and see what questions you all have in the audience. I'm sure you have fantastic questions. So thank you so much. And yeah, happy to take whatever questions you have.
All right, Susannah cannot see us, but she can very well hear your round of applause. Thank you so much, Susannah. We have indeed a couple of questions. In the meantime, I will quickly remind you guys that you can raise Susannah's talk after we are done with the questions. Please help us choose our speakers for our next conferences. That would be great. And also, most of the talks will be available soon on YouTube. So that's something to look forward to. And we have some questions. Susannah, I will read them for you.
Great.
All right. Doesn't doing responsible AI checks at each point of the development of ML or LLM-based models significantly increase the cost of the whole project?
Great question. So the short answer is doing something is always going to be more costly and time consuming than doing nothing. But the cost of building a model, training a model, and then reaching a point where it doesn't pass review and has to go through retraining and redevelopment from the beginning is much more costly than catching an issue with the model very early on in the development lifecycle before you've dedicated resources. And so ultimately, incorporating these kind of checks into your development workflow can reduce the risk of an AI system getting to that final checkpoint and not passing. And I think we've all heard this stat, which was from a couple of years ago, but there's a famous, I think, McKinsey stat that says that something like 85% of AI projects don't ever make it out of the lab, don't ever make it into production. A lot of that often has to do with the model reaching that sort of deployment decision point or that production level decision point and not passing critical governance checks. So this is a reality for a lot of companies, is that if they can catch those problems earlier on in the development lifecycle, they're actually saving a lot of resources on potentially wasted effort for a model that's never going to go into production because it's never going to pass that governance check.
All right, thank you very much. Next question, what are the principles or criteria to decide if a use case has responsible AI implications at all?
Great question. And this is not going to be a question that I can answer with just a blanket set of rules, because this is incredibly organization and context specific. That said, there are a couple of sort of dimensions that you can think about that are being instantiated in things like the EU AI Act that have this risk-based framework for thinking about use case risk of AI. One of the most important dimensions is, does this AI system impact individual humans directly, right? Is your system making decisions about people? Is it making decisions that are highly impactful to people? A back office system that's detecting defects in products that are moving down a manufacturing line has a very different human impact than that medical decision support tool that we were talking about earlier. So those two use cases you might want to put into different risk categories and treat differently in terms of responsible AI considerations. Now, that said, even the defect detection tool should have responsible AI considerations, right? You want to make sure that your defect detector is effective and is supporting the people who are working in the manufacturing line in a way that makes sense. But the level of care and consideration that you're putting into things like fairness of the system is going to be very different than the level of care and consideration when there's literally a human life or death decision on the other end of that system. So again, this isn't something that I can just give you a rule set for, but there are some general rules of thumb that often center on how human impactful that system is. And this is one of the most important things for you to think about supporting your organization in doing. Like, your company should be defining what is our risk framework for thinking about how our AI systems should be governed or not. And that should be something that gets consistently applied across all projects.
Right, makes sense. Thank you so much. Let's do two last questions. Do you think responsible AI is needed also for low-stake models?
Yeah, so as I was just saying, there are always going to be responsible AI considerations, even for a lower stakes model, but the level of effort and care that you put into really closely evaluating those considerations might be different, right? You might decide that A high-stakes model has to go through a really detailed review process with different members of your executive team to make sure that the model isn't going to harm the world or your company. But a lower stakes model doesn't have to go through all of those layers of review. It can go through an initial review to confirm that it's lower stakes and then get pushed to production with the right monitoring in place, right? So there are going to be levels of effort and levels of detail that you want to change depending on how high risk the model is.
All right, thank you very much. Let's go for the last one. Explainability and safety research in general seems to move much slower than capability gain, which seems like a dangerous dynamic. What should we do?
Great question, $1 million question. If I knew the answer to this question, maybe I would be running for president of the world, right? I think that there are a couple of things that policymakers and the responsible AI ecosystem have started to rally around, which I'm really excited about to address this, yes, absolutely very dangerous sort of set of race conditions that we're in right now. One is to commit a certain percentage of resources that are currently going towards development of new technical capabilities to safety research. So for example, requiring any organization that is doing technical research on AI capabilities to dedicate a certain percentage of that research budget to safety research. That's one very practical example of how we can change the incentives to encourage more safety research and not just technical capability research. Another really interesting idea is this idea of having centralized resources for research. So for example, in the United States, there's talk of creating a national AI research resource, which is basically a bunch of money that's invested into a centralized set of compute that's available for research and grants and things for research. And that money could then be allocated by the public, right? Versus research right now is primarily being driven by incentives of the free market and capitalism. And so of course, companies are incentivized to put a lot of research into thinking about how they can create capabilities that give them a competitive advantage. If we take some of those research resources and put them into the public domain, governed by public policy, then we might be able to incentivize more research towards the kind of externalities that we want to prevent, the societal well-being that we want to maintain. So those are two ideas, right? But I think this is an area where we need all of the ideas that we can get to figure out how we allow safety research to keep pace with technical research, how we avoid that existential risk that I was talking about earlier. So if you all have ideas, I'd love to hear them.
All right. Thank you so much, Susannah, for the great answers. Thank you, audience, for the great questions. I will let you go now. Susannah will receive from us a small gift, which she does not see, so it will be a surprise for her, as a small token of gratitude for participation. Thank you very much, Susannah, and let's give a round of applause.
Thank you so much.
Thank you so much for being here
everyone.
with us.